Yeah, hi, hello. Today, let us discuss about Kubernetes architecture in detail. Kubernetes. What is Kubernetes? Kubernetes is nothing but it is a container orchestration tool. It is a open source container orchestration tool used to manage and deploy the containerized workload. It is a microservice based architecture. This can be compared to Docker Swarm. And Kubernetes was owned by Google. The basic difference between Docker Swarm and Kubernetes, both will be working as same, but the basic difference between Docker Swarm and Kubernetes is Kubernetes can work for a use applications, but in other case, Docker Swarm unable to work as effectively when we use applications. And in another perspective, Docker Swarm leader or master itself acts as a one instance or one code, one container. But whereas if Kubernetes won't act as a instance, it only allocate worker load among the worker nodes. Okay, that is the basic difference. Now let us discuss about Kubernetes architecture. Yeah, this is Kubernetes architecture. First let us discuss about from user interface. See, this is the user or client, someone is trying to interact with Kubernetes master. How the process will be going on means the user is going to try to connect with Kubernetes master. We have something called as kubectl. Kubectl is nothing but it is a command line utility used to interact with Kubernetes master. Kubectl is mainly used to interact with Kubernetes master. And if you talk about Kubernetes, then here we have something called, we're going to have something called manifest file or configuration file. And manifest file or configuration file is nothing but it contains all the information or all the data used to run an application in the form of AML script. Okay. And if you, here we have something called as API server. API server is nothing but it going to receive an incoming request from manifest file, and it going to validate or scan entire the manifest file whether it is a authorized one or not. Then it is going to update it. And here we have something called as etcd. Etcd is nothing but etcd is nothing but it is some type of data, a database where all the information about the ports, about the containers is present. And it is used to, and we have something called as scheduler. Scheduler used to schedule our port. It going to check for the information or about incoming information from etdc from the database, and it going to try to allocate the instance or server port to according to it will going to schedule it. Okay, based on the requirement, based on the traffic, it going to allocate our port or instance by getting incoming request or checking the information about etdc. Etdc is I already told you that etdc is a single point of information or container where all the information about the port or containers will be present in etdc. It is nothing but a database. And we have something called as control manager. Controller management is mainly used, manager is used to make sure that higher availability of port or higher availability of application based on the traffic. Even though there is a high traffic, it will going to make the application or port to higher availability to the users. Control manager always continuously monitoring the code inside the cluster. Control manager is nothing but it is a desired state of code. It always check whether the application or code is running inside the cluster or not. And we have something called as worker node 1 and worker node 2. See, Kubernetes master will going to allot worker load among the worker load among the worker nodes. And if you talk about kubelet and crypt proxy, let me take another architecture video. See slide. We have already discussed that these are the things: etdc cluster, controller manager, scheduler, API server, or belongs to worker node, Kubernetes master. And kube proxy, kubelet, and container runtime, these are belongs to, this comes under worker node 1. Worker nodes, not worker node 1. How many worker nodes? It doesn't matter. This will be present inside my worker nodes. And the etdc cluster, controller manager, scheduler, API server will be present inside my or Kubernetes master. And if you talk about kubelet, it is one type of utility present inside my worker node. Kubelet is the command where all the actual deployment will be going on. Using kubelet only, we're going to deploy our application or code. It will be receiving an incoming request from the API server. Then it will going to check for the image, what is the image to be deployed from the Docker Hub, and how many replicas to be deployed. And then we have something called as container runtime. Docker container runtime is nothing but Docker engine. Inside the Docker, it is used to, it is then when we going to use Docker runtime, it will going to search for the image, whether the given image is present inside my Docker Hub or not. Then it will going to update it to the kubectl, whether it is present or not. After, if it present, that kubectl will going to use it for deployment. And here we have something called as kubeproxy. Kubeproxy is nothing but it is used to manage network. It is used to manage the network in between the API server and kubelet. In other words, it is used to establish the connection between Kubernetes master and worker nodes. Okay, mainly kubeproxy used to establish the connection between Kubernetes master and worker nodes. It's going to interact with API server with worker nodes. Okay, and we have something called, we have already discussed. We can use number of containers, okay, inside my worker nodes. See here, port 1, port 2, and port 3. And in detail, if you talk, this is core Kubernetes architecture. See, we have already told you that which are present inside my Kubernetes master. Inside my Kubernetes master, I have API server, scheduler, etdc, control manager. API server is used to validate or scan the manifest files, nothing but ML script. It is by when you are getting incoming request from ML script, it's going to scan and validate whether it is the authorized one or not. And we have something called scheduler. Scheduler is nothing but used to schedule our code. etdc, it is a single point of information or container used to schedule our code. Okay, control manager, it is continuously monitoring our cluster code inside my cluster, desired state of code. Okay, worker nodes, kubeproxy, it is a network connectivity between worker nodes and Kubernetes master. CRA, it is going to search for the image, whether it is present inside our Docker Hub or not. Then it will going to update it to kubelet, where the kubelet is used to deploy how many replicas to be deployed and what is the image to be deployed. And we have something called as pod. Pod is nothing but it is the atomic unit of scheduler. It runs the container. It is nothing but it's going to collect the control on the components. It collects the control components. In other words, pod is nothing but it going to it contains all the containers. Okay, it runs all the containers. And if you talk about Kubernetes architecture explanation, I already told app configuration file or manifest file. It contains all the data to run an application in the ML script. See, that's what I told you. Manifest file or app configuration, both are same. It contains all the information to run an application in the ML script or manifest file. We can call it as a app configuration or manifest file. And kubelet, it is a command line utility used to interact with Kubernetes cluster. That's what we have discussed. And API server, when we want to interact with Kubernetes, it receives an internal request. That's what we have discussed. Then it will go into validate or scan the manifest file whether it is authorized or not. etdc, we simply call it as database where we store all the information about the containers, or ultimately it is access a single point of information or container. And scheduler, it will going to schedule over the port. It is going to schedule our port. It will identify the request from etd database, try to allocate instance or server based on the traffic. Kubelet, it is the one type of utility that is running inside my worker node. It is used to deploy your port. It receives the incoming request from API server, which image to deploy, how many requests to be deployed based on the traffic, based on the script what we have be giving inside our ML script. And Kubernetes architecture, we have something called CRI, Docker Runtime Engine. It will search for the image from the Docker Hub. It brings to worker node if it's present, then kubelet will go into deploy it. Kubeproxy is used to maintain the network for the API server to interact with worker nodes. There is nothing but kubelet. In other words, it is used to establish connection between master and worker nodes. Control manager. It ensures the high availability of code and ensures that cluster is upward running. If you want to run 3 instances of code, it will go into upward running. It will continuously monitor our code inside the cluster, desired state of code. And we have something called as manifest file. Both manifest file and configuration both are same. It also alternate name for configuration file. Pod is the alternate name for container that are upward running. And pod is nothing but atomic unit of scheduler, what we have already said. And the main thing what we have to discuss about Kubernetes is Kubernetes cluster, where all the information about the worker nodes or all the deployment file, whatever maybe, all will be present inside our cluster, not Kubernetes master, inside my cluster. We can lose our Kubernetes master or Kubernetes instance, but we can't use cluster. That is why we call it as it is very important in the Kubernetes. Cluster is nothing but it is a collection of worker nodes. And if you discuss about VM container pod, see, in Linux we call it as virtual machine, OS platform. In Docker we can call it as container. In Kubernetes we can call it as pod. All these things are same. We're going to use all these 3 things are virtually itself, but in Linux platform we're going to use as virtual machine. It requires much space when compared to container. And container in Docker we're going to act as we're going to call it as container. In Kubernetes we're going to call it as pod. Okay. And here we have something called as managed services about Kubernetes. In Kubernetes, managed services in platform, in cloud platform. These are 3 cloud platforms which we are using highly nowadays to reduce our cost. On premises, it requires high cost. If you want to try it by our own, it requires a high amount to be invested on the services. For that use only, we will be prefer for our cloud platforms. That's what we call as AWS, Azure, and Google Cloud Platform. AWS is nothing but cloud, Amazon Web Services, Azure Web Service, Azure, and we have something called as Google Cloud Platform. If you talk about Kubernetes in cloud platforms, in AWS we can call it as Elastic Kubernetes Service. In Azure Kubernetes Service, and Google Kubernetes Service. And see hardware requirements. What are the requirements to run a Kubernetes inside our cloud platform? For running our Kubernetes, there are some hardware requirements. For running an hardware requirements, CPU. We require CPU, 1 CPU or more, and 3 GB of RAM is required. 2 CPUs. We require at least two CPUs, and we require at least 3 GB of RAM or more. Enable full connectivity across the cluster, the roads. We have to enable this, and disable Selenium, because in order to interact the host with worker node, we have to disable Selenium into 0, and swap up. We have to swap off both worker nodes and Kubernetes master. These are the hardware requirements. And if you talk about namespace, there is every time we're going to launch and install our Kubernetes pods, we have to deploy them with a default environment. Okay, we should not use it at default one. We have to use particular namespaces like QA or dev environment or UAT. Okay, namespace is nothing but it is a logical partitioning of cluster. And here we have something called as services. This is also very important. Kubernetes services. And in Kubernetes services, we have something called as cluster IP. Cluster IP, it is a default service. Cluster service is mainly used to communicate in between the ports. Node port. Node ports used to expose our port into internet level worker nodes. Both same. Node port is used to expose our port. The port which you have created by using ML script will be exposed to internet level using node port services. Okay, by giving port mapping. And load balancer. Here we have something called as load balancer. The load balance is used to distribute incoming traffic. See, if the traffic is high or low, we're going to distribute among the worker nodes and make the application or port higher availability to the user. And here we have something called deployment control object. We have already discussed it in the architecture. I will tell you. Use it to replicate. See, deployment control object will going to use it. It is going to continually. It is the desired state of code. It is used. It will be continuously monitoring our pod inside our cluster, whether it is upward running or not. Okay, what is going to do means it is going use it to replicate code on replicas based on the traffic. It's going to replicate. If you talk about the big billion days in Amazon shopping mall and Tatkal, at the time of level or 10 in the IRTC platform, IRTP services, if the traffic is high, based on that, the deployment controller is going to make the replicas. If the traffic is high, it's going to scale up. That is the main advantage of using this scale up and scale down. Scale up means it's going to, based on the traffic, it's going to replicas. And the scale up means it's going to make the replicas high. Now it is high, 5. If the traffic is high, it's going to scale up to 10, 15, 20 based on the requirement. If there is no traffic, then it's going to make it as scale down and make it based on the requirement. It's going to replicate and upgrade. Upgrade is nothing but we go if you want to take any particular version of the application, we can upgrade it, or we have to upgrade means we can upgrade to latest version. And we have something called rollback changes. These two are interlinked actually. See, we can upgrade it, but if your latest version is not working as our expectations, then we can roll back the changes. We can go for previous changes. I have already discussed about these 4 things practically in another video. Here we have this conclusion. A pod can run a single container, multiple containers. Kubernetes, using Kubernetes, we can perform continuous deployment and the effective working of pod or application. Okay, we can make a higher availability of application during traffic by using controller manager. Okay, this is all about Kubernetes. Okay, and we have something called we have to discuss about ML script. This is ML script. See, in ML script, this is the application. This is the version what we are using, API version. API version, what is the we are using? Kind is nothing but the kind of, whether it is a pod or service. We are using deployment metadata type of the object we are using, and the name of the object. Okay, and labels is used to, it is a tag for the object which we are using, and replicas. And here we have app name. This is the app name which we are going to create it. And space here it is also one type of tag. And replicas, how many replicas of our application should be replicated. That is what replicas. Okay, metadata, we have already, it is the object type of object, and labels is nothing but it is a tag for the object which we created. And containers, and we all know about containers. And the name of the image, it is the name of the image and with the version type of the image what we are using from the Docker Hub, and the image and with the version. And if you talk about rollback, and we have discussed all about this rollback. Okay, let me show you again. See, rollback changes and upgrade. Here, if you talk about, here I am using NJ 1.7.9. This is our question actually. If I want to upgrade, I'm going to use this command. By using this service, I'm going to update it. If I want to go to again to the previous version, means 1.7.9, then I'm going to use this rollback changes. Okay, this is the basic difference between rollback and upgrade. Okay, this is when we have something called as ports. Here we have to enable all the traffic when we are practicing. And if you talk about in the based on the real-time environment, we have to give the port numbers on a particular port number, on which port number we have to expose our worker node or port into internet level. Okay, this is the container port and the port number. And we have selector, it is also tag and the application name. Okay, this is all about, this is a deployment file, ML script. Based on this file only, our application will be running. The API server will going to scan it, and all the process will be going to be happening as we have discussed. Okay, this is all about Kubernetes. Okay, thank you. I hope I explained you very well. Okay. Thank you.